In our graphic here we're showing SmartZone 100s, but clustering is the same. The operations are identical across all platforms. The only restriction is that cluster nodes must all be of the same type. You can't mix virtual and appliance nodes in a cluster, and you can't mix high scale and essentials in a cluster. Clustering ensures high availability. Controllers replicate system data and operations between the cluster nodes. And because the data exists on multiple controllers, a single node failure doesn't impact operations. Within a cluster there's always a designated leader. The leader's function is to manage replication backup functions, and a detailed look at this is beyond the scope of this course. However, you should understand how to identify the leader as it relates to cluster redundancy, and we'll show you how to identify the leader later in this module. In this scenario we have an existing node configured as the first node in the cluster, so this is the first controller that you will have built. The second node has now reached the point in the setup wizard where it can be joined to the cluster. After the details have been entered, the controller will attempt to contact the cluster via UDP to the designated IP address it was given, and if configured correctly the existing node will respond. The new node will join the cluster and the two devices will synchronize the database schema. The setup wizard then displays a successful join. The devices then proceed to synchronize the full databases. Before we look at cluster failure, let's take a moment to look a little bit deeper at the cluster joining operations. So the first smart zone in a cluster will contain all of the databases, and there are a number of them. For this example we've sort of grouped them into categories, but there are many, and the databases run on the first controller that we create. As soon as we join a second controller, it will go through the setup wizard, join the existing cluster, and when we select that option it will synchronize all the databases from the first to the second. And after this point these databases are consistently synchronized between the two nodes. When we have multiple nodes, the databases aren't replicated to every controller. Instead, the copies of the databases are distributed across different nodes, and this leads to better data consistency. As there's only 2 copies of each database in the cluster to maintain and synchronize, the operations are a lot more fluid. Additional copies introduce higher likelihood of data becoming unsynchronized, so it's a much more efficient way of running. Any cluster member can save a configuration change or have updated access point statistics, for example. The cluster member will then replicate the changed data to the corresponding databases across the nodes. Admins can log into any of the nodes to view the GUI and monitor operations. Let's now look at how the access points communicate with the cluster, and we're using a 2-node SmartZone 300 cluster as an example because it allows us to describe the operations with multiple data interfaces. But don't forget, there are many ways to configure your interface settings. You may not use a data plane at all, for example, so your setup may be different. Also refer back to the module where you learned access point registration for a review of those operations. Well, first of all, the access point contacts the controller over the control plane using the IP address supplied by the admin and sends the registration request. The controller sends the SSH certificate and the controller list. This is the IP addresses of the control planes available in the cluster. And note, for this first access point, the addresses are in order, C1 and C2 pointing to the control plane addresses. The controller also then sends the data plane addresses, and again these are sent in a specific order. The access point now establishes connection to SmartZone 1 using the first control plane address. And finally the access point establishes a connection to the data plane, again using the first address on the list. Now when a second access point joins the cluster, the controller returns the control plane and data plane addresses in a different order. The second access point connects to SmartZone 2, and by changing the order presented, this is of the addresses that are presented to the access point, the cluster load balances the new access points across all cluster nodes. Let's see now how the node addresses are used for failover. In this example, the access point loses its control plane connection to the first smart zone. The access point then moves to the secondary control plane node address on the server list. Note that only the control plane tunnel moves. The data plane is still active, so the access point doesn't need to change it.